Suddenly you can't ask, so give me all the airplane in which this particular part occurs. Or give me all the components in all of the fleet whose maintenance interval is due next week. Suddenly it shows that in this particular example, you need not only graphic queries, but you need document queries as well, now using secondary indexes. And here it comes to the rescue that the graphs, the vertices and edges, are actually stored as document collections, which means you can just use a secondary index and index it in this way as well. So, multi-model shines if you have a complicated enough applications that, for performance reasons, you need both. You need graph queries and document queries and maybe key value lookups. And that's why I'm insisting that for the right definition of multi-model, you need a query language which allows to mix and put them together. So, for example, you want to be able to get some documents from the document store using some secondary index by some filtering. Then take each of them as a vertex in the graph, do a shortest path or some graph traversal, take the results, and then compute a join with those. That's something you want to be able to do, and only if you can do that, I would call it a multi-model database. Now, I'm coming to the sales pitch part, and I work for the company making ArangoDB, so therefore excuse the little sales pitch part. ArangoDB is a multi-model database, and it was designed as such from the first line of code written. Because back in 2012, we figured with all this experience with specialized data stores, what we would need to build all these things is something like